Hi everyone, Tarulli Tutoring here. Today we're going to be tackling the topic from the grade 12 Advanced Functions curriculum of solving quadratic trigonometric equations. Okay, so let's get started. We should know from grades 10 and even grade 11 that when we are solving a quadratic equation, not a quadratic trigonometric equation, just a basic quadratic equation, we usually take something in the form like this, right? And then we factor it, which is just expressing it as products, writing it as products. In this case, we would get x minus 5 and x plus 2. And then we would set each of these to 0. So we would say x minus 5 equals 0. And then x plus 2 equals 0. We'd solve for x and we get that x equals 5 and x equals minus 2, right? And these would be the roots of our quadratic equation here. This is how we would solve this normally. And we're going to actually apply the same principle when we are solving quadratic trigonometric equations. So let's take a deeper look at this. So say I have something, let's call this, I guess, example 1. So say I have something already in factor form. We have sine x minus 1, and then cosine x plus 1, and we're saying this is equal to 0, right? What we're going to want to do here is we're actually going to want to do the same thing. We're going to set each of these products equal to 0. So we're going to say sine x minus 1 equals 0, cosine x plus 1 equals 0. Solving for this, we get that sine x equals 1, and cosine x equals negative 1. Now, what we want to think about is where sine x equals 1, if we're thinking about our quadrants, right? Think about our cast model and our special angle relationships. Where is sine equal to 1, and where is cosine of x equal to negative 1? So, sine x equals 1 when we have a 90-degree angle, right? Or pi over 2. So we would say that x over here equals pi over 2, so x1, I guess. And then if we're looking at cosine of x, where does it equal negative 1? Well, cosine of x equals negative 1 at pi. Ooh, that pen is a little thin. Sorry, let's make this a little darker. All right, at pi. So we would say our x2 is pi. And those would be the solutions for this equation. x1 is pi over 2, x2 is just pi. And that's it. That's how you would solve this. But let's go through another example because we want to have some practice with this. Okay, example 2. All right, in this example, we have sine squared x equals 1 over 4. What we're going to want to do here is we're going to want to take the square root of 1 over 4. So we're going to say sine x is equal to root 1 over 4. However, when we take the square root of something, we want to always write in a plus or minus on the outside because this could be positive or negative. So we'll do that. And if we take the square root of 1 over 4, we get 1/2. So we get plus or minus 1/2 is equal to sine x. Okay, to simplify this a bit more, we say that sine x is equal to 1/2, and sine x is equal to negative 1/2. All right, so now we want to think about, again, where is sine equal to 1/2 in our cast model and using our special angles, and where is sine equal to negative 1/2? Okay, so let's start off with positive 1/2. Sine is equal to positive 1/2 at the 30-degree point, or pi over 6. It is also equal to positive 1/2 in this quadrant over here, quadrant 2, at 5 pi over 6, right? Because those are the quadrants where sine is positive. Makes sense. So we can say x1 is equal to pi over 6, x2 is equal to 5 pi over 6. All right, moving on, now we're going to want to look at where is sine equal to negative 1/2. while sine is going to be equal to a negative value in quadrants 3 and 4. So here and here. And this angle is going to be 7 pi over 6. And this one is going to be 11 pi. Oops. 11 pi, sorry about that, over 6. All right, so we can say x3 is equal to 7 pi over 6, and x4 is equal to 11 pi over 6. So there we go, we've identified the roots for this quadratic equation. Quadratic trigonometric equation, my apologies. All right, let's do another example. Okay, example number 3. Okay, in this example, we have 15 cosine squared x minus 8 cosine x plus 1 equals 0. What we want to do here is we're going to want to factor this the same way we would factor something if it was just a basic quadratic equation. Don't let the cosine x throw you off. We're going to treat this as if it was x. You can even think about it like 15x squared minus 8x plus 1. But then you're just going to make sure you write the x as cosine x. Okay, so we can factor this with our normal kind of cross method we were used, or whatever kind of method you were taught. So I'm going to factor it like this. And then when I do that, I get 5 cosine x minus 1. And then I get 3 cosine x, 3 cosine x minus 1. All right, so now that I have this, I am going to go ahead and solve each of these products. So again, I'm setting each of these equal to 0. I'm setting each of these equal to 0. So I have 5 cosine x minus 1 equals 0, and 3 cosine x minus 1 equals 0. I solve for cosine x. I get cosine x equals 1 over 5. And then cosine x equals 1 over 3. All right. So again, I'm going to want to find my different quadrants where this is positive, where cosine equals, positive 1 over 5. And that's going to be quadrants 1 and quadrant 4. So I would find those values, and the values you would get for those are 1.36 radians, and then 4.92 radians, and then same thing for cosine 1 over 3. You would find those quadrants, again, quadrants 1 and quadrants 4, because cosine is positive, and we would say x3 is equal to 1.23 radians, and x4 is equal to 5.05 radians. And that will be it. Those will be our solutions for this quadratic trigonometric equation. Let's do one more example. All right, let's call this example number 4. I believe it's example number 4. All right, so here we have 4 cosine 2x plus 10 sine x minus 7 equals 0. And at first glance, you might think, well, I can't solve this. I have a combination of cosine and sine x, like cosine 2x and sine x. Like, I don't know how to solve this because they're two different forms. I can't factor it. How do I solve this? And the thing is, whenever you have this kind of situation where you have cosine and sine, you always want to see if you can convert into one type. Because in other cases, we've seen this already factored for us. Like in the first example, we had sine x minus 1 and cosine x plus 1, but that was already factored. When it's not factored like this, you want to try to convert it into one, either cosine or sine, one general form. And there are a few ways you can do this. A really, really great way is to see what kind of identities you have present. In this case, we have a cosine 2x. And if we think back to our double angle identities, we can realize that we can convert to sine x using a double angle identity. So we know from a past lesson in advanced functions that cosine 2x is equal to 1 minus 2 sine squared x. Now we're going to use this to convert this whole quadratic trigonometric equation into the sine form. So either sine squared x and then sine x, whatnot. So then we can factor it using sine. All right, let's do that. So we say 4 times 1 minus 2 sine squared x plus 10 sine x minus 7 equals 0. Expanding that out, we get 4 minus 8 sine squared x plus 10 sine x minus 7 equals 0. All right. Continuing that on, we're going to get negative 8 sine squared x plus 10 sine x and then minus 3 equals 0. I'm actually going to factor out a negative 1 because I don't want to have, that 8 in the front. I want to be positive, so I'm going to say I'll factor out a negative 1 because I'm sort of 0 over here. It's not going to really do much, so I'm going to get 8 sine squared x and then minus 10 sine x plus 3 equals 0. Then I can just factor this normally as if I had a quadratic. Doing so, I get 4 sine x minus 3 and 2 sine x minus 1 equals 0. Again, now I'm going to set each of these equal to 0. So 4 sine x minus 3 equals 0, 2 sine x minus 1 equals 0. Solving for each of these, I get sine x equals 3 over 4 and sine x equals 1 over 2. And then if I go and I think of my cast model, where is sine equal to these angles? Well, we already know that for sine is equal to 1/2. It's in quadrants 1 and quadrants 2, and it's at an angle of pi over 6 and 5 pi over 6. So we can say x1 equals pi over 6, x2 equals 5 pi over 6, and sine x is equal to 3 over 4 is not a special angle, so we're going to have to compute this manually with our calculator. But if we went and we found out where, sine was equal to 3 over 4, it would still be in quadrants 1 and quadrants 2 because that's where sine is equal to a positive value. We would find one angle here, and then we would say pi minus that angle to get our next value. So we would say x3 is equal to 0.848 radians, and then x4 is equal to 2.29 radians. And those would be our solutions for this quadratic trigonometric equation. Hopefully this helped. If you have any questions about this topic, feel free to leave a comment down below or send me an email at Tarulli Tutoring@gmail.com. Thanks so much, and I hope you have a great day. Bye.